Dear students, welcome to digital class. I think all of you are eagerly waiting for today's class. In previous class, we have learned how to find out the surface areas and volumes of a singular solid and also surface area of combinations of solids. In this session, I am going to explain how to find out the volume of a combinations of solid and conversion of solid from one form to another form. So, before that, see a small activity. So, just to match the solids with their respective formulas. The first one, what is the curved surface area of cone? Now, children, identify the curved surface area of a cone. Curved surface area of cone is pi r L. Now, the volume of cuboid. Children, identify the formula of volume of cuboid. Yes, once again you are correct, that is LBH. Now, the volume of sphere. Yes, the volume of sphere is 4 by 3 pi r cube. Now, what is the total surface area of cylinder, children? Yes, 2 pi r into h plus r is the total surface area of cylinder. Now, children, the volume of cone. So, identify volume of cone, children, formula. Yes, once again you are correct, that is 1 by 3 pi r square h. And the same way, identify the volume of cylinder. The volume of cylinder. Yes, volume of cylinder formula pi r square h. Now, volume of combinations of solids. See, this is a oil tanker, and here I want to find out the volume of this complete oil tanker. So, the oil tanker is a combination of our known solids. Just name the solids. Yes, the first one is a cylinder, and second one is a hemisphere, and third one is also hemisphere. So, it is a combination of three solids: hemisphere, cylinder, and again hemisphere. Now, what is the volume of the oil tanker? Volume of the oil tanker is a volume of these three solids. See the formula. Volume of oil tanker is same as volume of one hemisphere plus volume of the cylinder plus volume of the another hemisphere. So, here the volume of the complete oil tanker is a combination of volume of the our known solids. So, we have the problems based on these concepts. Let us solve the problems one by one. See, children, an iron pillar consists of a cylindrical portion of 2.8 meter height and 20 centimeter in diameter, and a cone of 42 centimeter height surmounting on it. Find the weight of the pillar if 1 centimeter cube of iron pillar is 7.5 grams. Children, see, suppose this is a iron pillar, its cylindrical portion, and its base radius is given 20 centimeter and height is given 2.8 meter, and a cone is surmounting on it. A cone is surmounting on it, and the height of the cone is given 42 centimeter. So, what we have to find out? We have to find out the complete weight of this iron pillar. So, what we have to find out? First of all, we have to find out the volume of this iron pillar. Now, children, find out how many solids it has. So, yes, it is a combination of two solids. The first one is a cylinder and second one is the cone. So, the volume of the complete solid is same as volume of the cylinder plus volume of the cone. It gives the volume of the iron pillar. Then from that, then we can find out its weight. So, given data, height of the cylindrical pillar is h equal to 2.8 meter. So, convert into centimeter, 280 centimeter. Next, the diameter is given d 20 centimeter. Then its radius r equal to half of the diameter means 10 centimeter. Next, a conical portion means a cone is surmounting on the cylinder and its height is given 42 centimeter. So, first to find out the volume of this solid. So, volume of iron pillar is same as volume of the cylindrical portion plus volume of the conical portion. Now, children, what is the formula of volume of a cone and volume of cylinder? Yes, the volume of cylinder formula pi r square h plus volume of cone formula 1 by 3 pi r square h. Now, write the formulas. Pi r square h plus 1 by 3 pi r square h. So, write the remaining h plus 1 by 3 into h. Now, children, substitute the variable values. Pi value 22 by 7, r means the radius 10 into 10, r square means 10 into 10. Height of the cylinder is 280 plus 1 by 3 into small h means height of the cone 42. Now, see the cancellations, 3 ones are 3, 14s are 42. 10 into 10, 100, 100 into 22 is 2200 by 7. Next, here 280 plus 14 is 294. Now see the cancellation once again, 7 1s are 7 42s. Now children, multiply here the 2200 with the 42 and the answer is 92,400 centimeter cube is the complete volume of the iron pillar. Now what we have to find out? Weight of the iron pillar we have to find out, but it is given the weight of the iron pillar per 1 centimeter cube is 7.5 grams. For 1 centimeter cube 7.5 grams. Then we have to find out here for 92,400 centimeter cube volume, for this volume we have to find out its weight. So here what we have to do, children? Yes, the multiply 92,400 with 7.5 grams. So that gives the complete weight of the iron pillar and the answer is 6,93,000 grams. Now children, here convert this grams into kgs. So it is written as like this, 693 into 1000 grams. So what is the value of 1000 grams, children, in kgs? It is 1 kg. So 693 kgs. Next, find out the volume of a largest right circular cone that can be cut out of a cube whose edge is 7 centimeters. So children, suppose this is a cube whose edge is 7 centimeters and we have to cut out a cone from this cube. Children, suppose this is a cone that is cut out from the cube. And what is the height of the cone, children? Yes, the height of the cone is same as height of the cube, means edge of the cube, that is 7 centimeters. And what is the radius of the cube, children? Yes, the radius of the cube is half of the height of the cube, means edge of the cube. The edge of the cube is 7 centimeters, then its radius of the cone is 7/2 centimeter. So this is the cone which is scooping out from the largest cone from this cube. Given data, cube of edge 7 centimeter, the diameter of a cone with the largest volume that can be cut out from the cube of edge 7 centimeter is also 7 centimeter. Then the radius is half of the diameter, that is 7/2 centimeter. So children, see, this is a cube whose edge is 7 centimeter and this is the largest cone which is cut out from the cube. Then its diameter is 7 centimeter and height of the cone is also same as the edge of the cube, that is 7 centimeter. Now children, what we have to find out here? Yes, here we have to find out the volume of the cone. Now children, what is the formula of volume of the cone? That is 1/3 pi r square h. Volume of cone 1/3 pi r square h. Now substitute the variable values. 1/3 into pi value 22/7, radius is 7/2, r square means multiply 2 times and height h is 7. Now see the cancellation, children. 7 1s are cancel, 2 1s, 2 11s cancel. Next, see the numerator values. 11 as it is, 7 into 7 49, 2 into 3 is 6. Now the complete answer is 89.3 centimeter cube. Now this is our required volume of the cone, 89.3 centimeter cube. Let's solve one more problem. Children, read the question carefully and try to collect the clues. Spherical marbles of diameter 1.4 centimeter are dropped into a cylindrical beaker of diameter 7 centimeter which contains some water. Find the number of marbles that should be dropped into the beaker so that the water level raise by 5.6 centimeter. So children, this is a empty beaker and it contains some water. Now we have to drop spherical marbles in the water. We have to drop a spherical marbles in the beaker and the water level increases up to 5.6 centimeters. So how many spherical marbles we have to drop in the beaker to raise the water level 5.6 centimeter? We have to find out. See children, I am showing the process. Here a spherical marble dropping in the beaker and the water level increases. Observe carefully. Children, observe carefully. The water level increases. How much increases it is? Yes, it is 5.6 centimeter water level increases. Now what we have to find out? How many spherical marbles we have to drop to increase the water level up to 5.6 centimeters. So write the given data, children. The given data, spherical marble diameter d equal to 1.4 centimeter. The radius r is half of the diameter, 1.4/2 is 0.7 centimeter. So write in p by q form, means 7/10 centimeter. And the cylindrical beaker diameter, this is the cylindrical beaker, its diameter is given 7 centimeter. Then the radius is capital R equal to half of the diameter, means 7/2 centimeter. Next, the increased water level after dropping the marble in the shape of a cylinder with its radius. Children, the water level increased is in the form of a cylinder. So, here the height of the cylinder is same as 5.6 centimeter and the radius of the cylinder is same as radius of the beaker. The radius are equal to 7/2 centimeter and the height is same as the water level increases 5.6 centimeters. So, write in P by Q form 56/10 centimeter. Children, the required number of marbles formula, increased water level by volume of one spherical marble. Children, here I am going to explain how to write this formula. Remember, for problems based on this concept. So, increased water level by the volume of one spherical marble. So, always we have to write in the numerator the bigger solid value. See once again, always we have to write in the numerator bigger solid volume by in the denominator smaller solid value. So, here our given data, the bigger solid means it is a form of a cylindrical, the water in the form of a cylindrical, so that is bigger solid, and the smaller solid means the spherical marbles. So, in this way we can find out the required number of marbles or anything. Here the increased water level is in the form of a cylinder and the volume of the spherical marble means the spherical marbles is in the form of a sphere. Now, children, what is the formula of volume of a cylinder and what is the formula of volume of a sphere? The volume of a cylinder formula pi r square h and the volume of the sphere formula, yes, 4/3 pi r cube, pi r square h by 4/3 pi r cube. So, pi get cancelled. So, here r square h by 4/3 r cube. Now, children, substitute the variable values. So, radius r is 7/2, r square means 2 times 7/2 into 7/2. Height of the cylinder is 56/10, 4/3 as it is, r cube. R cube means the radius of the spherical marbles is 7/10, cube means multiply 3 times. So, children, here no need to calculate the division. I explain in a simple way, just to follow the method. Transpose the denominator terms into numerators. While transporting the terms, we have to write the reciprocals of the denominator terms. See, children. So, here the first 3 terms are the numerator terms, do not change it as it is, write it as it is. And while writing the denominator terms into numerator, write the reciprocals. See, 4/3 reciprocal is 3/4 and the 7/10 reciprocal is 10/7. So, in this way we can calculate easily. And see the cancellations, the first one 7 ones are 7 ones are and again 7 ones are 7 ones are. Next to 2 here the 7 ones are 7 8s are 56. Next to 2 ones are 2 5s are, next again 2 ones are 2 5s are 10 cancel. Next here the denominator term here the 4 ones are and 4 2s are 8. If you observe, all the denominator terms are cancelled. So, no need to calculate the division, just to multiply the terms the remaining in the numerator. Yes, they are 2 into 3 into 5 into 5, 2 into 3 6, 6 into 5 30, 30 into 5 150. So, this is the simple way of calculation, no need to take here the division. So, the number of required marbles are 150. So, children, the 150 marbles are required to increase the water level up to 5.6 centimeter in the beaker. Now, see one more interesting question. A pen stand of wood is in the shape of a cuboid with 3 conical depressions to hold the pens. The dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter and the radius of each depression is 0.5 centimeter and the depth is given 1.4 centimeter. Find the volume of the wood in the entire stand. So, these are the measurements of the cuboid, children. Length 15 centimeter, breadth 10 centimeter and height 3.5 centimeter. So, see, this is a pen stand. It is in the form of a cuboid and the length is given 15 centimeter, breadth is given 10 centimeter and height is given 3.5 centimeter. So, these 3 are the conical depressions because they are in the form of a cone whose radius is given 0.5 millimeter and the depth, children, here the depth means height of the conical depressions, that is 1.4 millimeter. Now, children, what we have to find out here? We have to find out the entire wood in the pen stand after removing the 3 conical depressions. So, what we have to find out? Yes, the entire wood volume is same as volume of the cuboid minus volume of 3 conical depressions. So, this is the pen stand and this is in this way we can put the pens in the stand. So, the volume of the cuboid stand is 𝗹𝗵𝗐. Substitute the values, L value 15, B value 10, H value 3.5 and the answer is 525 centimeter cube. Now, find out the volume of the conical depression. So, the first one, the radius of the conical depression r equal to 0.5 centimeter is same as half of the centimeter. Next, the depth is same as height of the conical depression. I denote with h, that is 1.4 centimeter. Convert into p by q form, means 14 by 10 centimeter. Now, children, the volume of each conical depression, it is in the form of a cone. So, the volume of cone formula 1 by 3 pi r square h. Now, substitute the values. 1 by 3 pi value 22 by 7, r means the radius 1 by 2 into 1 by 2, that is r square, height 14 by 10. Now, observe the cancellation, children. Here the 2 ones are, 2 11s are, 7 ones are, 7 2s are. So, here numerator terms 11 into 2, denominator sum 3 into 2 into 10. So, 11 into 2 22, 3 into 2 into 10 is 60 and the answer is 0.367 centimeter cube. This is the volume of the one cone, but we have to find out the volume of 3 conical depressions. So, multiply with 3. So, 3 into 0.367 gives 1.1 centimeter cube. Now, this is volume of 3 conical depressions. Now, children, what we have to find out? We have to find out the wood entire in the stand, same as the volume of the cuboid minus the volume of the 3 conical depressions. See the formula. The volume of a wood in the entire stand is same as volume of cuboid minus volume of 3 cones. So, 525 minus 1.1. So, the answer is 523.9 centimeter cube, that is the volume of wood in the entire stand. Now, conversion of solids from one shape to another shape. So, children, I explain this concept with an example. See, children, this is a sphere and I am converting this sphere into a cylinder. Observe carefully. Now, children, it is a cylinder form. So, what you have to observe here? Yes, I am converting the sphere in the shape of a cylinder. Now, what is the common thing, children? What do you notice? Yes, I am using the same material while converting from sphere to cylinder. So, what is the common thing? Yes, the common thing is its volume. So, remember, children, while converting the conversion of solids from one form to another form, the common thing is its volume. So, remember this concept, means while converting solids from one form to another form, the common thing only its volume. The volume is common. So, let us solve some problem based on this concept. A metallic sphere of radius 4.2 centimeter is melted and recast into a shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. The given data, the radius of the metallic sphere is 4.2 centimeter. A metallic sphere is melted and recast into the form of a cylinder whose radius is given 6 centimeter. So, what we have to find out, children? Height of this cylinder. See the volume of the sphere. Now, children, what is the formula of volume of the sphere? Yes, that is 4 by 3 pi r cube. Now, write the formula 4 by 3 pi r cube and substitute pi, put pi as it is, just substitute the radius r value. R cube means multiply 3 times, 4.2 into 4.2, 4.2, put pi value as it is and the answer is 98.7 pi centimeter cube. Now, same way find out the volume of the cylindrical beaker. So, volume of the cylinder is pi r square h. Put pi value, h value as it is, substitute the r value, that is given 6. So, 6 square means 36, 36 into pi into h is 36 pi h centimeter cube. Now, children, just now we discussed that the conversion of solids from one form to another form, the volume is common. So, according to our question, the sphere is converted into the cylinder. So, here the common thing is, yes, its volume is common. So, write the given data. According to the question, the volume of metallic sphere is same as volume of the cylinder. So, volume of metallic sphere is 98.7 pi centimeter cube and the volume of the cylinder is 36 pi h centimeter cube. So, from this we have to find out the h value and h equal to 98.7 pi by 36 pi. Here the pi get cancelled and the answer 98.7 by 36 gives 2.741 centimeter. Now, this is the height of the cylindrical beaker, that is 2.741 centimeter. Now, children, see one more question. A container shaped right circular cylinder having the diameter 12 centimeter and height is 15 centimeter Yes, it is a full of ice cream. The ice cream is to be filled into cone of height 12 centimeter and the diameter is 6 centimeter to making the hemispherical shape on the top. Find out the number of such cones which can be filled with the ice cream. So, children, see the given data. The container shaped cylinder, the diameter is given 12 centimeter, means its radius half of the diameter, that is 6 centimeter. So, height is given 15 centimeter. So, children, so this is a container shaped cylinder, its height is 15 centimeter, radius 6 centimeter, it contains full of ice cream. Yes, we have to empty this cylinder by filling the ice cream in a cones, ice cream cones. So, these are the ice cream cones, we have to fill up the ice cream cone with the ice cream, and here the top is in the form of a hemisphere. So, we have to fill the complete ice cream like this. So, children, how many ice cream cones are required to empty this cylinder? So, these are the cones required to make the cylinder empty. Now, children, how many ice cream cones are required to make the cylindrical ice cream cone empty? Now, children, what we have to find out here? We have to find out the number of ice cream cones that required to make empty the container of ice cream container. Let us find out the number of cones required. So, volume of cylinder. Now, children, what is the formula of volume of cylinder? Yes, pi r square h. Pi r square h. Substitute the r value, radius 6 square and height 15. So, here 6 square is 36 into 15. So, the answer is 540 pi centimeter cube. Next, the cone diameter is given d 6 centimeter, then its radius r equal to half of the diameter, means 3 centimeter. And also height of the cone is given 12 centimeter. Next, the hemisphere radius is r, it is given 3 centimeter. Now, children, what we have to find out? We have to find out the volume of this complete ice cream cone. The volume of ice cream cone is volume of the cone plus volume of the hemisphere. What is the volume of a cone formula, children? Yes, 1 by 3 pi r square h. And what is the volume of the hemisphere, children? Yes, 2 by 3 pi r cube. Now, substitute the 1 by 3 pi r square h plus 2 by 3 pi r cube. Take 3 common and pi also same, take pi common, r square r cube, the least degree is r square. So, take r square also common. So, completely 1 by 3 pi r square common. So, remaining terms are h plus 2r. Now, substitute the variable values. 1 by 3 pi, r value radius 3 into 3, r square means 3 into 3, h is 12, 2 into r means again radius 3. So, children, 3 get cancelled. So, 3 pi plus 2 into 3, 6 plus 12, 18. Now, 3 into 18 is 54 pi centimeter cube. Now, this is the volume of the complete ice cream cone. Next, the number of ice cream cones. I already told that the volume of the cylinder by the volume of ice cream cone. The bigger volume solid contained in the numerator and the denominator contains the smaller solid volume. So, bigger solid is given the cylinder and the smaller solid is ice cream cone. So, substitute the values. 540 pi by 54 pi. Pi get cancelled. 54 1s, 54 10s. So, 10 ice cream cones are required to make the ice cream container empty. Now, how many silver coins? 1.75 centimeter is diameter and the thickness is 2 millimeter. Need to melt it to form a cuboid of dimensions 5.5 centimeter, 10 centimeter, 3.5 centimeter. Now, children, these are the silver coins. Now, children, name the shape of the coin. Yes, the coin is in the shape of a cylinder. The coins are in the form of a cylinder and the thickness and the diameter is given. The diameter is given 1.75 centimeter. Thickness means nothing but height of the cylinder is given 2 millimeter. And these coins are melted to form a cuboid of these dimensions. Yes, children, this is the coins are melted and converted in the form of a cuboid. We have to find out how many coins are required to make a cuboid of this given dimension, that we have to find out. So, given data, the cylindrical silver coin diameter d 1.75, then its radius is half of the diameter, means 1.75 by 2. Now, remove the decimal point, children. So, while removing the decimal point, write in denominator 100, 2 into 100, 200. Now, cancel in 25 table. So, 25 7s are 175, 25 8s are 200. So, this is 7 by 8 centimeter, that is radius of the silver coin. and the height of the silver coin is nothing but thickness, that is 2 millimeter, write in the centimeter 2 by 10 centimeter. Now, Q by dimensions is also given, L, B, H values are also given, write in the P by Q form, L equal to 55 by 10, B is the breadth 10 centimeter and height is 35 by 10 centimeter. Now, the number of silver coins, again the same formula, the volume of the bigger solid by volume of the smaller solid we have to write here. In numerator, volume of the bigger solid, in denominator, volume of the smaller solid. In our given question, the bigger solid is cuboid and the smaller solid is silver coin. So, here the volume of cuboid formula children 𝗹𝗵𝗸 and the volume of the silver coin is in the form of a cylinder, that is pi r square h. Now, substitute the variable values, L value 55 by 10, B value 10, H value height 35 by 10, pi means 22 by 7 and the radius of the silver coin is 7 by 8, height of the silver coin is 2 by 10. Now, the same step here also, no need to calculate the division, just to follow the steps. Transpose the denominator terms into numerator, means transpose the denominator terms into numerators. While transporting the denominator terms into numerator, write their reciprocals. So, here the first 3 terms as it is in the numerator and the denominator terms are, write their reciprocals. 22 by 7 is written as 7 by 22, 7 by 8 reciprocal is 8 by 7, 2 by 10 reciprocal is 10 by 2. And children, see the cancellations carefully, 10 10 get cancelled, 10 10 get cancelled, 11 5s, 11 2s and 7 1s, 7 1s, again 7 1s, 7 5s. So, here 2 1s, 2 4s, here also 2 1s, 2 4s. Complete all denominator terms are cancelled, write only the numerator terms 5 into 5 into 4 into 4 and the answer is 400 silver coins. So, 400 silver coins are required to convert this into a cuboidal shape of given dimensions. Now, children, it is time to solve some problems. Note down the problems and solve the problems at your home and submit the homework to your concerned subject teacher. See those problems. We will meet in the next session with one more interesting topic. Until then, take care and goodbye.